Okie doke. All right, so I like to categorize this exploration as NTT. Name that too. All right, so I'm giving you table values, and you're trying to come up with the numerical processes that create these table values. And so you can pause the video and look at each column and try to tell me what y equals, where I'm getting those values from. What am I doing to the values on the left to get the values on the right? What numerical processes? And each table is built off of the previous one. So you pause the video and I'll just go through it. And each time we get to a new table set, pause the video, see if you can look at what's going on. And I think that you'll benefit from this process. I think it'll help you to understand mathematics a little more deeply. All right, so I'll start here. And what do I see? I see y equals 2 to the x. 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4. Reciprocals, right? Those reciprocals. So 2, 1/2, 4, 1/4, 8, 1/8, so on and so forth. And I also notice that the range, all these y values are greater than 0. They're positive. Okay, so it doesn't look like this function can kick out anything that isn't positive. I'm not seeing it. And I'm also seeing that this appears to be going to y equals 0. These fractions keep getting smaller and smaller and smaller on the left and bigger on the right, doubling process. And so that's what I'm seeing. Next, this table is based on this one. So you're pausing the video. Well, I'm not seeing any change in the x side of the table. No, I don't think I'm doing anything here. But it appears that 1 is now 5 because I'm still using a 0. So it's 5, and 2 is 10, 4 is 20. Oh, yeah, it does look like I'm multiplying my function by 5. Yeah, everything's going up. So whatever this distance is, this one is 5 times bigger. So I'm going up. It's like 5 times faster. Next set of table values. You're pausing the video. And I think I've done this in other videos. I think I've got another video where I've done this, but I don't have a whole lot of organization to my work here. So I thought I'd do it again because I think it's important that you see how to do these things. Okay, so let me look and see how things have changed. Whoa, my x values don't look, the column, the y column looks similar, but the x column doesn't. What have I done here? A 0, now a 3 gets me a 5. And a 4 gets me a 10. And a 5 gets me a 2. And all of these values here appear to be 3 bigger. 3 bigger. And I want this number to act like a 0. How do I make the number 3 act like a 0? Well, if you said 5 times 2 to the x minus 3, you'd have been right. Now 3 minus 3 is 0. 3 minus 3 is 0. 2 to the 0 is 1. 1 times 5, 3 gets me 5. Let's try a 4. 4 minus 3 is 1. 2 to the 1 is 2. 2 times 5 is 10. Let's try a 5. 5 minus 3 is 2. 2 squared is 4 times 5 is 20. Yep, that one looks like it's right. Okay, trusty science cart. Let's go to the next one. Should have moved this desk. Come on. There we go. All right. So now, this table is based on this one. I think you can see both of them. So I'm not seeing any change in the right side. I got a feeling I'm playing around with my exponents again. Now, a 3. 3 acts like a 0. Well, it still does. Okay, so that's here. So that and that. I got my eyesight where it belongs now. But instead of going up by 1, looks like I'm going up by 4. Going up by 4. Oh, I got to get multiples of 4 to act like jumps of 1. So if I put a 7 in, 7 minus 3 is 4. And I don't want that. I want that 4 to act like a change of 1. If you said, oh, I'm over here. If you said y equals 5 times 2 to the x minus 3 over 4, you'd been right. Let's check it. Let's put a 7 in. 7 minus 3, 4 divided by 4, 1. 2 to the 1, 2 times 5, 10. Yes, let's try an 11. 11 minus 3, 8 divided by 4 is 2 squared. It's 4 times 5 is 20. Well, let's try one more. 15 minus 3, oh, that's 12 divided by 4, that's 3. Yep, and that's exactly what it looked like over here. I jumped by 3 units. That makes it happen. 2 to the 3, 8 times 5, 40. Oh, okay. Looks like we have just one more set of table values. I think I should keep the last one there. All right, and now, oh, I've done something to my y values. Huh. Well, I think it's easiest to see 3 gets you 5 there. 3 gets you 6 over here. 7 gets you 10 here. 7 gets you to 11 there. Yeah, I think if you said that these y values have gone up by 1, then you're now looking at this problem from a numerical perspective, and that 1, new asymptote, basically still exponential growth. And let's take 2 values here. Let's go with 3 gets me 6. And let's go with 7 gets me 11. Not sure, I didn't take time to really look at that closely. And if I was doing this not from table values, but just this graph, then I would say, all of my y values appear to be bigger than 1. 6 is 5 units bigger than 1. 11 is not 5 units bigger than 1. No, 11 is 10 bigger than 1. And 3, I want that to act like a 0. And 7, I want that to act like a 1. And 10 divided by 5 is 2. Jeez, looks like if I just have a couple of points in an asymptote, I can construct these table values. All right, so that was just a little conceptual practice and seeing how some numbers work. Hopefully you might benefit from that. All right, let's shut this one down.